Okay, this is the assignment from Extension 2 in Module 1. And actually, I'm not going to do the early stuff. I'm just going to jump right to the ranking tasks. We can do some of the other ones in class, but I wanted to focus on the ranking tasks. The first ranking task, our job is to get the average velocity. So if you recall from our discussion in class, velocity is displacement divided by time. And we're looking at position versus time graphs. So there's essentially the fundamental way of getting around this one is to find out the change in position, that is displacement after all, and then the amount of time. So let's just take A for example. Notice what's happening in A. Our object at time 0 starts at position 0, and after 10 seconds it winds up at position 20. So again, the definition of displacement is where'd you wind up compared to where'd you start. You wind up at 20, you started at 0, the displacement is 20. So it's 20 divided by the time, which was 10. And therefore it's 2 meters per second is the average velocity there. For B, notice what's going on in B. It is a straight line. It's not a diagonal line. It's a horizontal line. What's the slope of a horizontal line? 0. Do you have an inkling that the average velocity might be 0? Again, it never hurts to actually put yourself in the mind, how would you have to be moving to create this kind of a graph? Well, to make this kind of a graph, you'd start out at position 20 and not move anywhere. You would just stand still for 10 seconds and you'd wind up at the exact same spot, at position 20 meters. And therefore your displacement is 0. So if you have a displacement of 0, I don't care how long you stand there, in this case it's 10 seconds, your average velocity is still 0 because it's displacement divided by time. And C looks very similar to A, but notice the difference is that you start out at position 0, you wind up at 10, so your displacement is 10, and it takes you 10 seconds to do it. So the average velocity there is 1 meter per second. In D, what's the big difference? Just look at those graphs. Notice that in D, you've got a diagonal line, but it's got a negative slope. You would expect you would have a negative average velocity here. And sure enough, if you try to walk it out, you think, where do you start? I start out at position 10. At time 0, my position is positive 10. After 10 seconds, where do you wind up? You wind up at position 0. Remember what displacement is. Where you wind up, which is 0, minus your initial position, which is 10, positive 10. So 0 minus 10 is your numerator there. That's your displacement. The time was 10 seconds. And therefore, sure enough, the average velocity is negative 1 meter per second. In E, you don't start out at position 0. You start out at position 2 meters. You wind up going to 10, so the displacement there is positive 8 divided by, again, the same time, 10. And what about F? What's physically going on there? Try to put yourself in your walking shoes and walk that one out. You start out at position 0. You don't just stay there, though. You move away from where you start. In fact, you go out to position positive 10 after 5 seconds, and you immediately turn her back around and wind up back where you started. What's the average velocity for that motion? Well, what's your displacement? What's your final position? 0. What's your initial position? 0. What's your displacement? 0. I don't care how long it took you to do it. I don't care how much walking around you did. Your displacement is 0. And therefore your average velocity is 0. So if I'm going to rank these, least would be situation D. Because remember that's negative. And negative is smaller than 0. So both B and F had average velocity of 0. That would come next. Notice that E has a velocity, an average velocity of 0.8, so that's going to be next. And then C. And then finally A had the largest average velocity, positive 2. And again, you can count them up, A, B, C, D, E, F. Everything looks good. That was ranking task number 1. Let's move on to ranking task number 2. Ranking task number 2, they want now average speed. Same graphs, now they want average speed. Average speed is distance divided by time. So you have to watch that out very carefully for that. So now if you're going to walk these out, we don't care about the displacement. We don't care where you wind up compared to where you start. We care about how far have you traveled during the 10 seconds you've been walking. So in A, you travel 20 meters in 10 seconds. So there's no change there. You still have an average speed of 2 meters per second. B, you don't go anywhere. You haven't traveled anywhere. Average speed, 0. C, same deal. You travel 10 meters in 10 seconds. Average speed, 1 meter per second. D, be very careful here. Yes, you're moving from positive values towards 0. You're moving from right to left, which is, it's a little unusual, but we don't care about direction when we're dealing with distance, and an average speed is distance divided by time. So I don't care if you're moving from right to left, left to right. If you move 10 meters, you've moved 10 meters. So in this case, we go 10 meters in 10 seconds. It's still 1 meter per second average speed. E, you go a distance of 8 meters in 10 seconds. Average speed, 0.8. F, be very careful with this one. Even though you wind up where you started, you did walk, you covered ground, and therefore you have a non-zero distance. You go out 10 meters, you come back 10 meters, a total of 20 meters in 10 seconds. So therefore, your 20 meters divided by 10 seconds, again, that's going to equal 2 meters per second. So in ranking these, notice I don't have any negatives. My 0.8 kind of looks like negative, but that's actually a decimal point there. They're all positive values. Why? Because average speed. And average speed is always positive. So therefore I ranked them. So now in this case, B, being 0, is going to be my smallest. Next would be E at 0.8. Notice that D and C are both tied. And A and F are both tied. And that's ranking task 2. Ranking task 3 really is just ranking task number 1 warmed over, because notice they want to know displacement. Remember that average velocity, which remember is V over, with a little hat on top of it, is displacement over time. So we've actually, when we worked out ranking task 1, where we found out the velocity, average velocities, what we figured out in ranking task 1, we did find out the displacement. The time was the same in all of them. It was 10 seconds. And therefore, whatever my ranking was from ranking task 1 should be the same as my ranking in ranking task 3. In A, I've got a displacement of positive 20. Notice I don't need to divide by time because they're not asking me for velocity. They're just asking me for the displacement. In B, displacement 0 because I didn't go anywhere. In C, positive 10. In D, negative 10. In E, positive 8. And in F, displacement was 0. I wound up where I started, and therefore 0 displacement. So I'm not even going to rank those because the ranking should be exactly the same as ranking task 1. Now we saw this in the last set of ranking tasks. It's another motion diagram. I want to find out the greatest average velocity in the first 3 time intervals. So it's very similar to the last ranking task in extension 1. In that case, we wanted to find out the displacement in 3 time intervals. This time we want to find out the average velocity, but again, remember that the definition of average velocity is displacement over time. I'm trying to write displacement over time. And it's still 3 time intervals, so my time is going to be the same in all these situations, so therefore to rank my average velocity, it's going to be the same as my displacement ranking from the last extension. So again, 3 time intervals, 1 time interval, 2 time intervals, 3 time intervals. My displacement, 6 meters. Let's say, they don't explicitly say that each time interval is a second. Let's say it's a second. So I've got 6 meters in 3 seconds, average velocity, 2. In B, 1 time interval, 2 time intervals, 3 time intervals. I go a displacement of 9 meters in 3 seconds, average velocity, 3 meters per second. In C, 1 time interval, 2 time intervals, 3 time intervals, displacement of 3 meters, time 3 seconds, average velocity 1 meter per second. Remember, these are all positive because my motion is from left to right. You can't, in this case, that would all be positive. In D, 1 time interval, 2 time intervals, 3 time intervals. Displacement, positive 6. Time, 3 seconds. Average velocity, 2 meters per second. In E, 1 time interval, 2 time intervals, 3 time intervals. Displacement, 6. Time, 3 seconds. Average velocity, 2. And finally in F, 1 time interval, 2 time intervals, 3 time intervals. I go from 0 to 4.5 in a span of 3 seconds. So therefore my average velocity, 1.5. I just realized this problem is slightly different than the last question in ranking task 1. But it's very, very similar. So anyway, to do the ranking then, I'm going to rank them from smallest to greatest. So C comes first at 1, then F. Now notice that A, D, and E all have the same value, so I'm going to have to squeeze them all into one blank. And then finally B was the largest at 3 meters per second. And that's it. That's how you do the ranking tasks from extension 2.